Every one of these ends with a line asking what you want broken down. Somebody took it up. Can you describe how image and video generation models differ from text-based models? Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. We will do it in that order, but the other way around. How an image is actually made, then video and text at the end, because once you have seen the picture machine properly, where text sits is genuinely surprising. An image model begins with a rectangle of pure random noise, television static. Then it removes a little of the noise, then a little more. 30 times, 50 times. What is left when it stops is a picture. The training runs backwards from what you would guess. Take a real photograph, add a little noise, then more, until nothing is left but static, recording every step along the way. Then train a model to undo one single step of that, just one step. That model can now walk one step back toward a real photograph. So hand it noise that was never a photograph at all, and ask it to walk back anyway. Do that 50 times over. It arrives somewhere that obeys the statistics of real photographs, having started from nothing. The important part is where the work happens. On every step, the entire frame is adjusted at once. Not a corner, not a region, not left to right. All of it every time, getting slightly less noisy and slightly more like a photograph. Same prompt, same seed, stopped at 5 steps, then 15, then 50. At 5, the whole picture is already laid out. The fox is where the fox goes. The snow is where the snow goes. The ears are in the right place. Every single color is wrong. That is what all at once looks like, and it is why there is no first pixel and no first anything. Not a finished corner beside an empty frame, the whole composition arriving early and vaguely, then everything sharpening together. Nothing was ever done before anything else. The other thing in that clip is worth your money. 15 steps is already a finished photograph. Fur, whiskers, catchlights in the eyes. 50 took 3 times as long and is not 3 times better. If you are paying for 50 steps by habit, check whether you can see the difference. Look closer, and the framing moved between them. Same seed, same prompt, and the 50-step fox sits differently from the 15-step one. Step count is not a quality dial on a fixed image. Change it and you walk to a different place. That is the real reason an image cannot arrive gradually the way text does. Not bandwidth, not the interface. Before the last step, there is no finished part of that picture to give you. Progress previews are real, but they show you an unfinished whole, not a finished piece. Nothing in there decides it is finished. You set the step count before it starts, and if you ask for more, it keeps refining. The model never volunteers that it is done, because being done is not a state it can represent. Too few steps, and you ship the fog. Your prompt does not enter at the start and get carried out. It applies on every single step as a pull in a direction. Guidance scale is how hard that pull is. Set it low and the picture drifts off your prompt entirely. Set it high and it obeys, but goes oversaturated and stiff because you have overridden the model's own sense of what a photograph looks like. People read that as the model being bad. It is the dial being wrong. So a prompt is a direction, not an instruction. Nothing in the process ever compares the result to your sentence and corrects it. That is why no hat can give you a hat. There is no step at which anybody checks. One more control worth knowing. The seed chooses which random static you begin from. Same seed and same prompt means the same starting noise, so the same picture comes out. Change the seed and you are starting from different static, which is a different picture entirely, not a variation on the last one. Worth knowing how words ended up able to steer any of this, because for most of the history, they could not. These were separate lines of work that only met recently. In 2014, generating an image meant adversarial training. This is the paper, Goodfellow and colleagues, and the highlighted line is the whole idea. We simultaneously train 2 models. One produces fakes, one tries to spot them, and you stop when the fakes hold up. It worked, and it was famously unstable, easy to collapse, hard to steer. 2020 brought the diffusion paper, the machine described a minute ago. The highlighted line is where the 1,000 comes from. We set T equals 1,000 for all experiments. 1,000 steps to walk noise back to a photograph. Slower than adversarial training, far more stable, and it kept getting better as it got bigger. Stable and scalable beats, fast and fragile every time. There was still no way to tell it what you wanted. Models that understood words and models that understood pixels were separate worlds with nothing translating between them. You could generate a plausible image. You could not ask for one. Then the paper that connected them, and if you keep one thing from this, keep this one. 2021, clip. The highlighted phrase is the scale it took. 400 million image and text pairs. Its job was not to generate anything at all, only to put a picture and its caption in the same place in a shared space, only to agree. That is what makes typing a sentence and getting a picture possible at all. Your words become a location in that space, and the denoiser is pulled toward it on every step. The direction from 2 scenes ago is that location. Before clip, there was nothing to aim at. Latent diffusion, the same year, made it cheap. The highlighted phrase is the trick, the latent space of powerful pre-trained autoencoders. Rather than denoising the full pixel grid, compress the image first, run every step in that much smaller space, then decompress at the end. Same idea, a fraction of the compute, and the only reason any of this runs on hardware you own. Video is where the intuition breaks hardest, so start by throwing one away. A video is not a stack of independently generated images. Generate each frame on its own, and every frame is fine on its own. While the shirt changes color, the face reorganizes, and the background boils. You already know why, from the seed. Each frame starts from its own random static and walks to a plausible picture. Nothing requires the plausible picture it lands on to be the same one its neighbor landed on. Both are valid. They are just not the same shirt. Which means consistency cannot be fixed afterwards. The frames are denoised together as a single object, with attention reaching across time as well as across the picture. Frame 12 can see frame 11, while both are still noise. Coherence has to come out of the generation. Which is why video is expensive in a way images are not, and why the clips are short. You are not simply paying per frame. Attention across time makes the cost grow faster than the frame count does, and that is why video tools price by the second, while image tools price by the picture. That is the picture machine, end to end. Now the part that was asked, and the answer is stranger than a list of differences. Text came down a completely separate line of descent, and this is its founding paper, 2017, Attention is all you need. The highlighted line reads, in this work we employ H equals 8 parallel attention layers, or heads, built for translation. It became the general architecture for sequences, and every text model you have ever used descends from it. What that architecture ended up doing is this. A text model reads everything written so far, scores every token that could come next, and picks one. It picks from a fixed list of about 100,000 words, fragments, punctuation, settled before training starts. It never adds to that list and never invents a symbol. 4 properties fall out of that, and not one of them exists anywhere in the last 10 minutes. Discrete items off a fixed list, produced in order, each final the moment it is made, and a hard ceiling on total length. The image model picks from no list because it adjusts continuous values that can land anywhere. It produces nothing in order. Nothing is final until the last step. And ask how long an image can be, and the question falls apart. A 512 pixel square costs the same whether your prompt is 4 words or 40. Which is why none of the controls carry across. Temperature and top P describe how a pick is made from a ranked list, and no pick is happening. Steps, guidance, and seed describe a denoiser, and there is nothing to denoise in a sentence. So you would draw the line between text on one side and anything with pictures or sound on the other. That is the wrong line, and speech generation is what proves it. A speech model runs that same loop exactly. Reads what it has so far, scores every possible next token, picks one. The list is not words. It is a vocabulary of sound fragments, small slices of audio, and a converter turns the finished sequence into a waveform at the end. But the machine is the text machine, with the ceiling to prove it. The speech model on this machine stops at exactly 1,000 tokens, about 44.8 seconds of audio, at roughly 22.3 tokens a second. A hard limit on a sequence, the same shape as a context window. Cross it and the clip is truncated with no error at all. So the line does not run between text and media. It runs between models that predict a next thing off a list and models that refine a whole thing out of noise. Text and speech on one side, image and video on the other. What comes out was never what mattered. To answer the question directly, a text model builds an answer up, one final piece at a time, off a fixed list. An image or video model brings a whole frame into focus at once, out of noise, with nothing final until the end. Everything else is downstream of that one difference. So, no partial image while you wait means nothing is broken, because there is no partial image to have. The step count is yours, and nothing will tell you it was set too low. Your prompt is a direction, not an instruction. And nothing you learned tuning a chatbot transfers, not the settings, not the failure modes. That was a question from the comments, and it was a good one. If something in this stack still does not sit right in your head, leave it below, and it might be the next one of these. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next.